XML, yeah, being one of them. You can do it in XML if you like, you can do it in JSON to it. Tends to be that JSON's used more these days to it. XML was the prior technology. It was still very widely used, and you'll find a lot of data coming out in XML, and we will have a look at some sort of documents coming through. So you receive, say, a sensor reading, and there it's called a measurement reading. It doesn't really matter what you call the tags, as long as your user knows what those sort of tags mean. That sort of data, you might add some attributes to it. But somebody's got to decide what that XML document looks like, and then you're into understanding perhaps a bit about XML to it, about how you have to have closing tags, root elements, case sensitive, all that sort of thing, well-formed XML documents. People who are on, say, the enterprise programming course will be more aware of this, because their whole assignment there is about web services sending out data in different formats. But somebody somewhere has to define a schema for what's meant in this case by a measurement. Now, a schema is just like a data dictionary. It's a way of defining what that data is. Now, this is what they're trying to do in standards. All these sort of global organisations are trying to decide, what should represent a measurement, so that we can all agree in the IoT community that this is the definition of a measurement. To it. Rather than individuals saying, well, this is my definition of a measurement, and somebody else has a different definition, that doesn't really lead to interoperability. And you need to have some standards organisation really laying down the rules. And it may be, like an Olympic, that somebody like Microsoft comes along and says, I'm the standards organisation for this, I'm the major player in it, I'll decide what these sort of things should be. Now, ideally, it's done with a consortium, but they will define this schema document of what types of data look like, so that other people can then reference that. Much like it's already happened for HTML. Everybody now agrees about what HTML5, say, looks like. We're all working to a common standard. And if we didn't work to that common standard, then all the browsers would react differently. If you could make up your own version of HTML, it just wouldn't work on certain browsers. Those browsers only understand HTML5 when it sort of comes in. They don't understand my HTML. So there is a need for these sort of standards to sort of get around for it. And it doesn't matter whether or not you call it measurement with values, units and times, or sensor data with reading, timestamp, long and lat. So long as you're in agreement for it. So long as you have got some sort of markup for it. And ideally something that's intuitively clear. You will then sort of follow, the users of it then follow that particular definition. But there's only really one standard out there that should be defined for it. As I say, currently, it's a bit fluid, really, for the IoT. It's not particularly being sort of defined for all these different sort of types of sensors. There's big players out there. There are people who are sort of suggesting ways. But certainly if you're doing something, again, to do with a project, this should be forming part now of your research that you're doing. If you're exchanging data in any ways, who's saying what those data formats should look like? What's a sort of common standard that you're going to work to? Or are you going to define your own for it? Are you going to be taking over the world because your standard's the best one for it? Now that's really all that's of use for us in this. That you can agree on what the vocabulary is and the primitives that you're using in this particular language. That works fine on a small, stable community. I might say, look, in this particular class here, we're all going to use this standard, and you all have to follow this sort of standard. And that's great. I can tell 120 people in this class, you must do it this way. You must submit on Moodle. You must submit these sort of documents to it. It doesn't necessarily work outside of that. So it works for a small and stable one, but it doesn't work very well on a larger scale. You've got to have a wider collaboration going on for something like that. There's a whole sort of, this is great if you're doing, say, information systems type degree, or something that's more over on the research side, less practically orientated in terms of programming. The whole bit about how you design the sort of vocabulary and languages for it. Now we're not going to sort of touch on it too much here. There is a bit of further reading in here about what's meant by the semantic web for it and how that's sort of working. And I'll leave this as a bit of background reading for what we call we're currently here with the syntactic web and how it's sort of moving on. Well, just as an example of where it is, we're in this thing called the syntactic web, where we can find stuff, and people think, oh yeah, it's great using Google, you can just type in what you want and the answer appears to it. There are some Google searches that you can't do to it. And people are like, what? I don't believe it. Google doesn't know something? Because, you know, if you're ever in a pub quiz, people are just frantically Googling on their sort of phones, and a good pub quiz developer needs to develop something that can't sort of be found. Now, a harder one, for example, might be, say, I want an image of Nick Whittaker, Darren Dancy and Paul Marsden all together. How are you going to get that through Google? You might be able to Google those three things and hopefully sort of come up with, it doesn't give you the answer straight away. So you might be able to find sort of separate images, and if I just sort of load that in Google to it, then Paul Marsden bump sort of came out at the top. It's my image to find what sort of pages where three are mentioned. Then it suddenly starts off on genealogy for it. Find information about animals that use sonar but are neither bats nor dolphins, like a barn owl. You'll try and use your sort of Google on something like that. Or things that are in data repositories. Things that Google doesn't necessarily have access to. So like travel inquiries, you're trying to find the cheapest flight. Google will have to have access to all these sort of, and they are getting better for it. Prices of goods and services, things where they're hidden behind firewalls to sort of get to it. So some of the things are fairly difficult to do, where you have to delegate tasks to sort of web agents for it. So that sort of thing, where you could go into a travel agent and say something like that, and after a bit of discussion, they might sort of come back to you. But be a bit tricky just sort of pasting that into Google for it. Anyway, there is a sort of section just related around that, and the rest of this chapter does talk about those sort of challenges that are involved, and we'll look a bit more at some of the challenges of IoT towards the end of this sort of series of lectures. But we'll leave it there for today. The lab that you're doing this week is this MQTT. So, see you in the lab this afternoon. Everybody miss the registrations down here at the front.
Yeah, do it.